So now in this video we're going to do a step-by-step build of this circuit right here. So I did a bunch of shorts recently. That's really all that gets monetized these days. We have 5 volts at the supply there and up to 0.1 amps of current. That's because we have a capacitor that can charge pretty much instantly a burst of current when we close the switch. That's another reason why I'm not using a larger value capacitor there. Larger value capacitor, the more current will be shorted to it, and higher currents kind of damage components and stuff. Maybe even a very low value resistor in series right there would help protect things, but we're going to keep this simple. Now we are focused on the NPN bipolar junction transistor. So you just need a weak signal from the base to emitter. So left pin is emitter, middle pin is base, and right pin is collector. When you're looking at the flat side, we got the part number right there, but it probably won't show up on camera. Maybe it will with the loop, and might have to move the light. But in case, yeah, won't be able to read the part number, and my lamp, it's probably time to replace it. It's connections are kind of going bad. Okay, so yeah, you can read the part number right there, 2N3904, and then those other letters and numbers, you'd have to check the data sheet of the actual company that manufactured it. So it's probably just a generic transistor made in China that those numbers may not even actually mean anything. So be aware of that. And so we want to put the emitter to ground right there. So yeah, somebody commented why we got the load on the collector side. So how much current that can flow through the collector depends on how much current is flowing from base to emitter. That's something to always keep in mind. So we don't want the load affecting the transistor at all, other than limiting the current through the power supply and the collector. We just want the transistor to either turn on or off for the most part, but as the capacitor discharges, we'll get into a middle ground region where the transistor is not on fully. But in any case, we don't want the load to affect how well the transistor conducts, other than limiting the maximum amount of current that flows through it. Now, we have, again, 2N3904 on the board, emitter to ground. And we're going to add our load. So, I'm going to light an LED. So the short lead, the cathode, goes towards the more negative side of the power supply, and the long lead, the anode, which long lead is on that side of the schematic symbol, short lead is on that side, as long as you haven't cut them. And you should say anode and cathode instead of short and long. But that's what we have here, a long and a short. So we're going to put the long up one row, and then the short right where the collector is. And then we got the resistor. And by the way, the order here doesn't matter, but resistor makes a better jumper than an LED, so we are going to put it in this order. And I don't have to worry about accidentally connecting to ground, because we got ground there, ground down there, and that's a no voltage difference. So we don't have to worry about making an accidental short circuit like that. Something to keep aware of whenever you have the power supply on. So power supply is on, and you can see we got that path, but the LED is not lit. That is because transistor is not on yet. This is a 10,000 ohm resistor. You commonly see that in a circuit like this. Commonly see a 10,000 ohm base resistor. And I'm actually going to put it over here really quickly to a row where nothing is connected, and you should already be able to see the LED is glowing a little bit when I touch the resistor right there. It's kind of like an antenna, something to keep in mind. If that's a problem, you got to address that. But this circuit, that's not a problem. So we don't have to worry about that. And I'm coming down to the other end of the switch down there. So we have the positive side of the switch, and this upper part I should say, is connected to the positive supply. The lower part of the switch, and I'm kind of reaching across here because these 2 pins within the switch are always connected to each other, and the top 2 pin are always connected to each other. You can see if I take the resistor and go to the positive supply, first off, that actually turns the transistor on. We kind of gave it a false signal that turned it on a little bit. Now it is on. So those 2 are always connected. This is one way, like if you need like 6 holes for some reason. And you know, this only has 5 across. You can use a switch like this that will bridge the gap, you know, especially if you need a switch. So we can have all kinds of stuff coming to the top there or something, and when I press the button, it'll connect to the bottom one. But in any case, that's not part of this circuit. We're not going to dwell on that too much. And I'll move it a little bit away from the switch because I need room to press that. So yeah, now we just have a basic switch demonstration circuit. Of course, we could just switch the LED with the mechanical switch. You know, we don't need a transistor for this particular circuit. The main takeaway is the switch is only letting a little bit of current to the transistor, and the transistor is switching a higher amount of current. So that's what makes it an amplifier. Weak signal is controlling a bigger load when it comes to power. That's the main thing. So once you're aware of that, you know, you wouldn't really build this circuit anymore. It's just for demonstrations. Now we got the 100 microfarad capacitor. Again, it's getting shorted to the positive supply, you know, just briefly, so somewhat high amount of current flows. Again, that's why I did 0.1 amps. We would be fine with 0.2 amps, 0.02 amps I should say right there, which is 20 milliamps of current. It would just take the capacitor a little bit longer to charge, and I'll show you something else while we're there. So yeah, we got the capacitor. This shorter lead, you know, I kind of bent them so that it will fit in the board for different reasons. Polarized. That side has to be more negative. We do have the value written on there, 100 microfarad, although sometimes it kind of runs off weird. So that says 100 over there, microfarad. And you can charge this up to 50 volts. So you don't really ever have to charge it up to 50 volts. That's the maximum right there. If you leave it, you know, just a little bit charged, 5 volts or something, that's plenty fine. These ones you probably don't want to completely discharge them all the time. And so just be aware of that to purposely. But even if you completely discharge them, probably won't harm anything. They kind of depend on their charge to maintain their polarity. Just be aware of that. If you reverse charge it, it could reverse the polarity on there, and you might get a short circuit or something along the way, and some bad things might happen. So I always try to keep, you know, like a little bit of a regular charge, but you know, don't panic a lot. Definitely don't reverse charge them. They can actually explode if you suddenly reverse charge it, and you know, you put too much current and voltage across it. But in any case, now our circuit is done. We'll kind of shuffle this way, right there, press the button, and there you can see right now the LED is fading off instead of just turning off instantly because we have the capacitor right there. So we could use lower value. I did a bunch of videos recently. We could use a lower value resistor in order to make it go faster. But capacitors, when it comes to all these components on here, the capacitor is the expensive one versus the transistor, LED, and resistors, and maybe even the switch. But in any case, capacitors are the more expensive components. They get cheaper as they get smaller. And so, you know, you might as well use as low of a value capacitor as you can. You can always use a higher value resistor in order to add more time, you know, if need be. But in any case, if you have a whole bunch of a certain value capacitors, then you can adjust the resistor value to set how long this takes. And I did a bunch of measurements. Ultimately, the capacitor, again, shorted to the positive supply, will get to the 5 volts. That is at the rail, because that's what we're powering with. Now it's discharging. The voltages are going down. It actually goes down fairly quickly at first, and then it kind of tapers off. The LED, you know, got a little dimmer. Then you can tell with your eye. But, you know, relatively quickly it got dim. And then it was really noticeably dim, and it kept getting dimmer. So it got dimmer quicker at first. It was on, transistor on completely for a bit right when I released, but then at some point, probably now, it's like going down, and there you can see it. It goes down quickly at first and then more slowly over time. Again, I did recent shorts where we looked at that. So yeah, I think I covered everything, but if I didn't, oh well, you know, we covered plenty. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. And if you like these longer format videos, go ahead and let me know, and I'd probably make more of them, but I really need to make shorts right now. If I just make regular videos, YouTube's not giving me views and stuff, and I make like half as much money as what I've been making now, so I can't do that. So thanks for watching.